So let's how to build machine learning model using Azure Custom referring to the official Microsoft at what is intelligence with the same. So this enables us to build custom image classifiers and image the identifiers add label based on the visual characteristic. We look at AI model. So the prerequisites for the session are you must also have Visual Studio Code as well as Git. So the learning tips for this session are, first of all, we need to set up Visual Studio Code and Azure Custom Vision. Then we will learn how to train a machine learning model and we'll also test the same on us. Looking up at the official definition of the artificial intelligence, that is computers doing things that we would normally think of as intelligent in humans. This quotation was given by Rick Baraz, Microsoft. This definition means just things that humans do. It's not that hard, but humans do all sorts of dumb things that much simpler animals do. But before we talk about how artificial intelligence works, we first need to know what is natural intelligence that comes in general human beings. Moving further, we can also compare artificial intelligence to how we are as humans. Like in humans, we take some sort of sensory input and then our brain acts as a model which initializes how to think and how to act upon the input given, and our behavior or response is given based on how our model is trained. That is, whatever our reflex or our brain commands our body to do, that is our response. If we think about how we as humans process information, it is not different from AI. Even in AI, we take input from the world, sights, in form of sights, sounds, and information. And we process that through our model, which has been trained by both nature and nurture. Input in what would be termed behavior. So now we have taken a look at how humans process input and output. Next, we move to machines. Similar to the human brain, with artificial intelligence, we can set up robots and other machines to behave intelligibly. We feed data as input to our users, and then based on the model that we have built, we get the answers. Moving ahead, the data is used to create programs and the image is loaded into the model. The model then responds with the answer. For example, if we give a set of cells and we have to identify whether it is diseased or not diseased, we first mark the diseased cell as red and the healthy cells as green. And then using different algorithms, we can learn and understand the patterns to help identify whether a cell is healthy or not after we have trained our model. And And after a model is trained, we take up a new set of cells that the model hasn't seen before and it identifies so that the forecast or the result, whether the cells are diseased or not, is given. And we must keep in mind that our output cannot always be perfect. We need to understand that artificial intelligence will not give us perfection, but will provide the correct result for a useful percentage of the time. Moving further, as you can see in the presentation, when we want to classify something, we provide a mixture of inputs and as represented as a funnel. Here the funnel is analogous to the model which we train, and the model separates the classified objects into two different categories. Here, as we can see, the red and blue. Not just classification, we must need another inputs in which we need the output in numerical form, in which we have to predict how much or how many is the answer, not just a category. In those cases, we use regression. And regression helps us predict a real value for new data given trends in example, like we can use regression to predict sea level rise, the chances of a forest fire, or how many people will be born in a given year. Next, we can see how to determine anomaly in a model. Anomaly can be anything which is separate or unique from the given set. This can help us detect security risks or malware or any unexpected behavior in our model. In case of a disease cell, any anomaly can help us detect which cell is cancerous and which is not. The next up is the reinforcement learning. And in the reinforcement learning, we see we don't train the model beforehand. Instead, on the real time, we give the feedback to the model and it trains itself with the experience. For example, there is an Envision AI app, which is a computer that beats a human at chess. It is a reinforcement learning model which has learned its moves after it has gained reward or punishments based on the steps it has taken. And the last, we have clustering or recommendation systems, which is also an important part of machine learning models. Get if we get to the structure or like if we want how to classify our next book or our next movie, we need this recommendation system. Under this is unlike classification because in classification our categories are already defined, but in case of clustering, after the model is trained, the categories are grouped itself based on the features. All the things that we looked at is enabled by machine learning. You all must be confused about artificial intelligence and machine learning. How are they related? So machine learning is a subfield of the artificial intelligence. Technically, machine learning is a method of data analysis that automates analytical model building. But artificial intelligence systems are a technique which don't need to be specifically programmed. Looking more at the difference, as you can see in the artificial intelligence is the models and data science fields that we have come across till now. It is the subset of the artificial intelligence, and neural networks is the superset of deep learning, followed by machine learning, which is the superset of neural networks as well. But machine learning is still a lesser part of the artificial intelligence. And all of these, which are the subsets of artificial intelligence, require statistics. So we very well know now that computer science and mathematics are very interrelated to give us an intelligent model. The overall field of AI, as mentioned in the presentation, includes machine learning and which in turn includes neural networks and deep learning. And both of these fields need computer science and mathematical intelligence in varied degrees. Moving ahead, we have already looked at classification. So based on this illustration, I hope you will never forget how to build a model on classification. But today, what we are going to build is going to use classification. It is the process of identifying which type the item is. Very common type of classification is image classification. We can use image to identify whether it is a type of animal or it is a type of fruit or whatever the kind of object is. While it is possible to build our own model from scratch, but it is a very common problem to those who haven't had uh, coding from scratch in machine learning. That's why we have come to the rescue to Azure Custom Vision. Azure Custom Vision solves the problem for many organizations and people who just need model building for their system, and the products already exist. We just need to train a service which uses a pre-built model. We will then be able to use the service like we use any other cloud-based service. We finally introduce to the custom vision. Custom Vision is a part of the Azure Cognitive Services. Azure Cognitive Services are very common for not just vision, but other machine learning models as well, for such as regression, clustering, and whatever models we discussed earlier. Custom Vision is just a small part of it. It is just a cloud-based service that allows us to create a custom image classification model. We can create our model in just 3 steps. We need to upload our images with labels. And using the pre-built service in the Azure Custom Vision, the model will be trained. And if we enter the test data or any random data on which we need to gain insights, we evaluate the results, and the results are shown on the screen. The labels that are entered in the image enter as categories. The categories are helpful to display what classification the test image will be in, and the model is trained in the cloud. We will now try a hands-on on how to build a custom vision model. To do that, we first need to create an Azure account. To create an Azure account, we will go to the portal.azure.com. In the portal.azure.com, you can sign up with your email ID and you can get a free tier service for using various resources that occurs on the Azure platform. Here, we are going to create a resource that uses custom vision. So in the Azure service, you need to click create a resource. This is the first step of our hands-on exercise that we are going to do. And after our resource is created, we need to search for the custom vision. Click on the create button and we can try with a different ID. Yeah, with this ID. You can also get Azure in your free tier for students' benefit. If you are enrolled in a college or in a university, as long as you are a student, you have free access to a lot of resources. The first thing that we need to enter in this resource that we will be needing keys for our application. So the both option needs to be selected. And every resource that we create needs to be a part of a resource group. And if we don't have a resource group, we need to create one. And every resource group in free tier needs only one resource. So now, as you can see, we have created a new resource and we need to select the nearest region. We'll be using Southeast Asia and you need to give a custom name that is unique. For example, and the as you can see, it is already in use. So let's give some numeric digits. We need to select 3 and here also free because we can't pay any price. So let's proceed. Or we can also see because it doesn't cost any fee. Okay. So next, all networks should be selected. We don't need any tags right now. Let me check if we need. We don't need any tag, or we can we just need to create, review, and create. So we can see all the networks on our internet will be able to access this resource. This is the final step. It will take a few minutes before our template is deployed. When we are done with the deployment, our next step will be to train the model. For training a model, we will create a project in the Azure platform. The platform will not need any coding experience. We just need to use the GUI interface so that our model is trained. Meanwhile, we are training this. You can take a look at the official documentation given by Google. So we can take a look at that later. Our deployment is complete. We will next move how to create custom vision projects. For that, you need to search custom vision on the internet, or you can enter this URL and we need to sign in with the same ID with which we are using the Azure platform. When you start for the first time, you'll need to agree to the terms of service. Then we will create a new project. And as we are going to create a classification project, so here we'll click on new project. We will name it. We will be classifying dogs on their breeds. You can leave the other fields as it is, or you can name the project as dog classification. The resource that we will be using is the same which we developed in our portal. As you can see, Custom Vision AK6410. Classification, multi-class, a general, and then we will create the project. So the process will be completed in a few minutes. After the project is created, we need to load the training images which are available in the official starter documentation repo. So to load the repo, you need to clone the repo. That's why in the prerequisites, it was mentioned to have Git knowledge. So as you can see, I have already cloned the repo. The workshop template is the repo that we'll be using, and into it, I have loaded it in the desktop. So let's take a look at the folder system. Inside the repo, you can move to the ML model custom vision and you can see a set of training images in it. So these are the images that will be used for training the model and classifying. And then there are the testing images that we'll be using to test whether our model is trained properly or not. So let's move back to our Azure portal. So here we are going to add images. In the desktop, we'll move to the folder, ML model custom vision, and the training images. So as you can see, we will be selecting only the classifying category. Here we have the first category as American Staffordshire. So we'll be selecting all of them and we will name it as the category is. Similarly, we'll have to upload other images with their categories as well. Click on the add images, then add the next category. We can also use list. It will be easier to take a look. So next will be Australian Shepherd. We have 5 category in this. Adding file. Next we'll be adding the Bugle category, which has 8 images to train. And as you can see, as you're uploading the classified category, it is listed on the left-hand side of your screen. The more the classification categories and the more training images, the better the model will be trained. So this is our German buyer here. And we have just one more category to put. That is short key. After we are done with our uploading the model images, we will train the model. And we will be using a quick training method so that our model gets trained immediately. In the top right hand corner, as you can see, a train, and we will click on quick training. It will take a few minutes before the model is completely trained, and you can see the iterations that are performed. If you did this process manually, you needed to write the code for training the model, for fitting, for transforming the images, for converting the images into code. And after this model will be created, we will need to test the model. So while the model is being trained, let's move to our presentation. So the attendees that are having, you might have question about how the model is working. Inside the Azure, all the models are a closed universe. That is, it knows what it's being trained on, and it will only attempt to match the images that the tags it knows. If you have given a category, and if you try to test the image of the category that doesn't fit to any, it will be an anomaly for it. There's always some level of uncertainty in the pre-built models, but it is always good to use it for a long run. Like if we, in case of image classification of a dog, if you upload the image of a house or any other object, it won't be able to detect anything. And the level of certainty will depend on what we are trying to create. It is good if the accuracy of your model is above 80%, and it is the general rule that gives how good the model is trained. To improve the accuracy, we need to add more images to it, which adds more diversity. This can include adding images of various backgrounds, various lightings, angles, resolutions, etc. So this is all about how our model is trained in the background. After our model is trained, the next step would be to perform a prediction. And the prediction is done based on the classification category that we have put. We first install the package that is required. We will have a hands-on on it right now. There will be three key values that we'll be needing for us for our project. And the key values are available in our Azure portal on the resource that we have created. And using the SDK is a software development kit that needs to be used to perform the prediction. So next, let's check if our model is trained or not. It's still training. So let's take a look on the next step. We can, by the time, take the keys and values that we will be needing for our model. It is available on this resource. So let's move to our resource. So this is the resource that we have created. To build the application, we need to move to the keys and endpoint section. And this is the endpoint that we'll be using. We can copy it, keep it on our system. We'll be using VS Code to build our system and to create the project. So let's open VS Code. Open the VS Code in the repo that we are using for our system. Like we can navigate to our repo that we have created. If it's visible properly, you can see the training folders and other files as well. We'll be using a .env file and a requirements.txt file that we need to install onto our system. So let's create by the time a .env file, a requirements.txt file. In the .env file, we will store the key point, endpoint, so this will be our endpoint, whatever we copied. Next, we need our prediction key and our project ID. So let's move to our Azure portal again. And we also need to check, as you can see, our model is trained. So in this iteration ID, we need to get the prediction key. We have already trained the model. So our next step would be to test the model. And using the quick test, we will be doing that. So after our model is trained, let's perform the quick test. We will enter the image from the testing images, which are very different from, you need to enter one image at a time. And after it is loaded, as you can see in the predictions, it has given the probability that it is the image of the dog is of the category American Staffordshire. However, as you can see, it is not 100% accurate. Therefore, it also shows some probability for other categories as well. Given that they are all dogs, so they might have some similarity about it, obviously. So for another, we can also test another images like the last one, Shocky. We can be sure that the name of the image that we are giving is not used for the prediction. It is totally using the characteristics of the image to make predictions with the utmost probability. And here it has predicted correctly that it is a Sharky with 99.8% probability. For the last time, let's check Australian Shepherd. So it has predicted correctly again. So our quick test is successful. Now we need to publish our model. And to do that, in the Performance tab, we need to select Publish. Here. And the name of the model, we can give simply dogs. The resource would be the same. And then we'll click Publish. It will take a few minutes. And as you can see, it also has the image count of the number of training images that we have put. As you can see in the .env file, we needed a prediction URL as well. So we will take the prediction URL from here. And the prediction key, we will be adding the same as it is given here. I hope my screen is visible of the Visual Studio Code. So this is the key given after our model is published. And our project ID. Project ID can be found in the settings. So let's take a look at the settings. This is the settings icon. And you can see here is the project ID. We will copy it and put it in our code. And our published iteration name is dogs as given. So all the credentials are added. We will save the file as here it is auto save, so we need not to do anything. And in the requirements.txt, we need to add python.env and the Azure Cognitive Service. This needs to be installed, the SDK that I talked about. And after we are done, we will activate the virtual environment on our repo. So let's click on New Terminal. We need to navigate to the folder in which we are creating the files. We need to go to then the name is ML model custom vision. So now we'll enter the command to activate the virtual environment. After a virtual environment is created and activated, then we will use the requirements.txt. It will take a few minutes. This is the last step for our model. After our virtual environment is created, we can simply add the image from our local system to test the images. After all the packages are installed, we just need to add a python.py file, predict.py file, in which we'll be adding the code. You don't need to write the code specially. You can get it from the official documentation as well. It will take less than few minutes to install the requirements. By the time we can create the predict.py file onto our system, the code for that Python file is really very simple. So the very first time we need to import the important libraries to load the keys and the credentials that we have added. We need to import .env, and we also need to import the custom vision and MS REST authentication and the operating system. Next, after we have loaded all the important libraries, we will set the values that we have created in the .env file by the load.env function. As you can see in the key variable, we have added the os.getEnv method to add the key. Using .env, our credentials are stored and is not visible publicly on the internet if you ever upload it. By this method, it keeps all your credentials safe from any attacks and other mishaps. So the next step is to add further code. This is a variable in which all the clients will enter the endpoint. By endpoint, it means the official URL on which you are going to enter the test images. You don't need to run every code yourself or type every code yourself, as we are trying to learn in no code environment. And after this is the last step of our predict.py. Now we'll try to run it. I think it is not logged in. We will be able to see our all output after we have logged in with our custom models. This is all about how we have created our custom model and tested it on our system using the quick test. All the methods showed on the screen right now have been used to create the custom model. What's more is after we have learned how to create image classification, we can also learn about object detection and TensorFlow. Let's take a look at those as well. So this is the official repo that you will be using to create your models, and you can copy the starter code from here as well. The configuration tools as told in the prerequisites. If you have any doubt, you can refer here. The first step was to install the configuration tool, and then we trained our model after creating the project. So all the steps, if you have missed any, is also available here. And the last step was how to test and use the model. So this is how we tested and used as well. And the next step that I mentioned was object detection. So you do have object detection and TensorFlow models too for Microsoft documentation. Let's take a look at that as well. All these documentation is completely free, and anytime when you want, you can create an account and start learning to it. The duration is very short, and you can learn a lot of content in this short duration as well. As you can see in this object detection, it has given the example of root classification and how you can implement it on Azure using the same custom vision method that I took the hands-on right now. And you can use the model. You can also export the custom vision models to your projects like Python, or you don't necessarily need to use it on Azure platform only. And the next I talked about was the TensorFlow documentation on the Microsoft. So every step-by-step method is given. And the last is the knowledge check. It consists of the simple question to brush up whatever knowledge you have. So next we move to the TensorFlow. TensorFlow fundamentals are very important if you are keen on learning how a machine learning model works. So you know TensorFlow works using Keras, and in this module, you will learn how a TensorFlow model works and how computer vision can be implemented with TensorFlow, how natural language processing can be implemented with TensorFlow, or how can you get introduction to audio classification and customizing TensorFlow beyond Keras as well. So these modules are a bit long in duration, but the content is worth the while. So you can, anytime when you are free, you can just Google it up and get this module and Microsoft Learn package. And you will get the badges after you complete each module, and you can show it up on your resume as well. So this was all about our workshop. I hope you learned a lot to it. So we'll be ending the session in just a few minutes. So thank you, everyone. I hope it was a useful one.